Hey everyone, in this lesson we are going to study one of the most important tools in trigonometry, that is calculating exact values of trig functions. Now, my goal is to make you smarter than your calculator. So I want you to not be dependent on your calculator and calculate exact values for trig functions without having to depend on that thing. Now, of course, there's some values that we need the calculator for, but many values you can calculate. Now, you have memorized exact answers for 0, 30, 45, 60, and 90 degrees. And if you haven't, get there. Make sure you can do those. And if you can do 0, 30, 45, 60, and 90, then you can also do radians of 0 radians, pi 6 radians, pi fourths radians, pi thirds radians, and pi halves radians. Now, with those exact value memorized, those are all quadrant 1 angles, and you have the reference angle to many other functions. So that's what we're going to explore. How do we calculate exact value for trig functions, particularly on radians? So I'm not going to concentrate on the degrees. Most students find the degrees pretty easy to figure out, but the radians take a little bit more thought. So that's what this is for, so you can focus on the radians. All right, so this is all going to begin with the reference angle property. And the reference angle property is what makes this all real easy. It basically says that you can take a trig function. I'm just going to use sine as an example. Sine of a hard angle. This is one you haven't memorized yet. Well, the sine of a hard angle is going to have this exact same answer as the sine of the reference angle. Which is an easy angle. So numerically, these two equations are going to have the same number answer. The only difference is the hard angle may be in quadrant 2, 3, or 4. And so, like, if the hard angle is in 3 or 4, the answer will come out positive or negative. If hard angle is in 3 or 4, it'll come out negative. So you do have to make a decision. Is it positive or negative? So there's always a choice there that you have to decide. I'm going to say decide, not choice. Okay, so that's something you have to decide. Now, the way you decide on the positive and the negative is to use our acronym A SMART Trig class, because all of them are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive if the angle is in quadrant 3. And cosine is positive if the angle is in quadrant 4. So that's how you can use that tool to help you to choose between positives and negatives. I've opened up an extra screen here because I want to give you a visual logic presentation to help you be convinced that when you take the sine of an angle, it's the same answer as the sine of the reference angle. In fact, for any trig function with an angle in it is equal to the same trig function with in fact, I'll change colors here for emphasis, with the reference angle inside of it. So the trig function of an angle equals the trig function of the reference angle. Numerically, you get the same. Now, there is one additional thing we have to think about. Should the trig function of the angle have a positive or negative answer? And that we can get from the quadrants. But it does make the calculations of trig functions of many other angles possible, angles that we haven't memorized yet. So that's the game plan here, and hopefully this visual presentation will help you feel more confident in that and feel more able to use it. Let's look at a few examples here. So the first example I want to look at is an angle over here in quadrant 2. So we are in quadrant 2, and theta equals 5 pi over 6. And if I want the reference angle is going to have to be this piece right here. Now if I notice the relationship between the green angle, the 5 pi 6, and the reference angle, it stops right here on pi. And so I'm going to convert pi into fractions of 6 because my original angle is 5 pi 6. It's out of 6. So I got 6 pi 6ths. And with that, I can notice between 5 pi 6 and 6 pi 6 that the reference angle has to be pi 6ths. So I calculated the reference angle real quickly. But I also want you to notice something else. The reference angle, we can create a triangle around it, and the triangle is in quadrant 2, of course. And so the x value to the unit circle is a negative 3 pi halves, and the y value to the unit circle point is a positive 1/2. But those numbers are exactly the same as these numbers. And this angle, we could go and prove all of this, that this angle is also pi 6ths. Now in quadrant 1, we've memorized all these ratios for pi 6, 30 degrees in this case, but I'm going to concentrate on doing this in radians. So we've memorized pi 6. So we've memorized these ratios of 3 pi halves for the cosine and 1/2 1/2 for the sine. We can use this to help us calculate this problem here. I want to find the cosine of 5 pi over 6. Now we've never done that, and we've never memorized it, and we're not going to memorize it. But it is hard. We haven't done this before. But we have the reference angle property, which says, wait, I can convert this hard problem into an easy problem. And the easy problem is use the reference angle instead. So convert the hard angle into its reference angle, and these are going to have the exact same values. You can see it in the green triangles. The green triangles are equivalent to each other. And because they're equivalent to each other, the numerical values for the radius, the y value, the x value are all the same. The opposite adjacent hypotenuses are all the same. So when we do cosine adjacent over hypotenuse, we're going to have the same numbers for the triangle in quadrant 2 and the triangle in quadrant 1, which makes it easy for us to calculate because we've memorized these outcomes for that first triangle in quadrant 1. And so numerically, we know that the cosine of 5 pi 6ths is the x-coordinate, or it is adjacent over hypotenuse, which is going to equal the square root of 3 over 2. Now, there is one slight adjustment to this calculation. Cosine of 5 pi 6 has an angle 5 pi 6 in quadrant 2, and we have a decision to make. Should the cosine of 5 pi 6 have a positive or negative? And that's where we got to think back to our acronym for the quadrants, a smart trig class. We are in quadrant 2. And in quadrant 2, sine is the positive one. So we can deduce from that that cosine and tangent are negative. So for this final answer, since 5 pi 6 is in quadrant 2, we have to choose a negative answer for the cosine. So there it is. That's my final answer. Now I did that based on what I memorized from quadrant 1, and that is the reference angle property. Let's try another one here. So let's consider an angle. I'll make it orange here, this angle right there. So I am in quadrant 3, and the angle I'm giving you in this diagram is 5 pi over 4. And say we want to calculate, this time, sine of 5 pi over 4. Now this is not one we've memorized. We don't know what this is. This is a bit hard for us because we haven't done angles bigger than the first quadrant before. Now, but what I want you to notice is the reference angle. The reference angle is right here. It's the red one. And so my angle, 5 pi fourths, stops right here. And if I had gone halfway, I'd be right here at pi. Now pi is a whole pi. Let's make pi a whole pi into a fraction of fourths, which is 4 over 4. 4 divided by 4 is 1 whole pi. And now if I want to find the red angle for the reference angle, I just noticed that the red angle is between 4 pi fourths and 5 pi fourths. I just have to subtract those. And I find out here that the reference angle is 1 pi fourths. So this hard problem, I can switch into an easier problem, changing 5 pi fourths into its reference angle, pi fourths. Now I do have to accommodate later the decision between whether it should be a positive or a negative, but by switching 5 pi fourths into its reference angle, I can do this because I've memorized sine of pi fourths. Now, if you're still struggling with radians a little bit in your brain, you're thinking, I hope you're thinking, pi fourths, that's like 45 degrees. So think pi fourths, that's sine of 45 degrees. So hopefully you've memorized those. And you're going to get 1 over the square root of 2. So sine of 5 pi fourths equals 1 over the square root of 2. Now we also have to make a decision about plus or minus. And so a smart trig class. Our angle is in quadrant 3 and tangent's positive in quadrant 3. And we can deduce from that, well, sine and cosine are not positive, they're negative. So we have to choose the negative ratio for this, and we're done. Now, just as a quick side note here, you can see the unit circle, they used square root of 2 over 2. And for students in my class, if you use 1 over square root of 2, that's fine, memorize that. But if you memorize square root of 2 over 2 as the sine of 45 or sine of pi fourths, that's fine as well, because these are equivalent. If I multiply square root of 2 over the square root of 2, that equals square root of 2 over square root of 4, which is the square root of 2, and square root of 4 is 2. And so numerically, the square root of 2 is the same as 1 over the square root of 2. This is my choice. I just prefer 1 over square root of 2. It saves me some work, and I just memorize it that way. That was just a little side discussion there. Let's do one more. Okay, so let's take a quadrant angle in quadrant 4. All right, there's my theta. So my quadrant has its angle in quadrant 4. And my angle in this scenario is going to be, let's see, 5 pi thirds. Now, you got to draw the 5 pi thirds, and you got to know where it is, and you got to get used to drawing those. But this 5 pi thirds does land me into quadrant 4. And let's say we're trying to calculate the tangent of 5 pi thirds. We have not memorized this. We don't know what this answer is. So what we're going to do is we're going to convert this into an easier problem. All we need is the reference angle. Okay, well, what is the reference angle? The reference angle, recall, has to go off of the x-axis. So it's not over here. That's wrong. It's not that red angle I drew is on the y-axis. My reference angle is over here on the x-axis. So in the reference angle there, notice how it completes a full circle. The purple angle and the red angle complete a full circle of 2 pi. And my angle finished here at 5 pi thirds. Now, the difference between the 2 pi, the purple one, and the 2 pi, the full circle, is my reference angle. I just have to subtract those. But 2 pi is not a fraction of 3, so I'm going to convert that by multiplying by 3 on the top and the bottom. And so 2 pi over 3 becomes 6 pi thirds. So 6 pi thirds divided by 6 divided by 3 is 2 pi. That's the full revolution. And if you notice, the difference between 6 pi thirds and 5 pi thirds is my reference angle. It happens to be 1 pi third. So this hard problem, I can simplify tangent of 5 pi thirds. I can simplify it into the tangent of pi thirds. Now, all I have to do to finish off is accommodate for the correct positive or negative outcome. Tangent of 5 pi thirds. 5 pi thirds is in quadrant 4. So, it should tangent of 5 pi thirds be positive or negative? Well, this positive or negative comes from the quadrant, a smart trig class. And so since we're in quadrant 4, it is cosine that is positive in quadrant 4. Now tangent then, we can deduce is negative. So we got to choose the negative outcome for that. So now we're doing tangent of pi thirds. Now you should be thinking in your mind, oh wait, pi thirds, that's the same as 60 degrees. So I have to do tangent of pi, tangent of 60 or pi thirds. And it's negative, so this problem is going to equal negative, and the tan of 60 is the square root of 3 over 1, which we don't need. There's the final answer. So we've memorized the tangent of 60, that's square root of 3, so that's the tangent of pi thirds. So we got the numerical value really fast, and then we got the negative part of the answer from our quadrant analysis using the acronym A Smart Trig class. So I'm hoping that's helping you see some of the logic. Speaking of the logic, look at the purple triangles. There's a purple triangle in quadrant 4, which is exactly the same as the purple triangle in quadrant 1. And this is what allows me to get the same numerical value for my angle in quadrant 4 as my angle in quadrant 1. The two purple triangles have the same x, y, and r values. They have the same opposite adjacent hypotenuse values. So the tangent is going to come out whether I do it in quadrant 1 or quadrant 4. Same back here, these two orange triangles. These two orange triangles are equivalent to each other. And so the reference angle of pi fourths is the same angle over here. So I memorized the triangle in quadrant 1, the opposite adjacent hypotenuse relationships, but it's the same opposite adjacent hypotenuse values that are in quadrant 3 on that triangle as well. So this is what makes the reference angle property work really nicely. Okay, with that, hopefully that's helped with a little bit of the logic in this. Let's practice some more. All right, let's practice the reference angle property just a little bit more. And I'm focusing on radians. Once you get the hang of this, most students can figure out how to do this with degrees a lot more easily than with radians. So that's why I'm concentrating on the problem with radian inputs. And you got 3 layers to each problem. Cosine of 4 pi thirds, that's our first example. And we haven't memorized that. And you don't have to memorize it. We're going to convert it into its reference angle. So you got 3 steps here. Figure out the reference angle. Then come up with the cosine of that reference angle, and then come up with the right positive or negative answer. So first, you may need to draw the angle so that you can calculate the reference angle. Some of you are more analytical and you don't need the drawing. But if I go this far, I've come 3 pi thirds. That's not far enough. So I'm going to take my angle a little bit further to 4 pi thirds. And then I can see, oh, here's the reference angle right in here. That's the one I want. And I can get that from subtracting. So I see the reference angle is equal to pi thirds. So this problem that I'm doing here is going to have the same answer as the cosine of pi thirds, except I have to choose positive and negative. So I've done one of the things. So far I found the reference angle. The next thing I've got to use my memory and calculate and show what is the exact ratio for cosine of pi thirds. Now in your mind you can be thinking, oh wait, quote, cosine of pi thirds, that is 60 degrees, and I've memorized that one. That equals 1/2. All right, now we have to choose, is it positive or negative? And we decide the positive and negative based on the quadrant. We are in, I didn't write that down, but 4 pi thirds landed in quadrant 3. And so from our positive and negative outcomes, we learned this A-smart trig class. Tangent is positive in quadrant 3. We can deduce from that that the cosine and the sine are negative. So I'm choosing the negative answer. So cosine of 4 pi thirds equals negative 1/2. Done. Got it. So with those 3 steps, you can give me an exact value of lots of trig functions. This we didn't need a calculator for. We didn't have to memorize this quadrant 3 outcome, but we wrote it down exactly without a calculator. Let's try another one of these. Let's go over here to the second one. 7 pi 6, where is that? Well, to kind of visualize it, if I draw a half circle, that's pi, which is 6 pi out of 6. 6 out of 6 is 1. 6 divided by 6 is 1 whole pi. And so that half circle that I've drawn is not big enough for 7 pi sixths. I have to draw it just a little bit further. And I also know in here is my reference angle. That's what I got to find. And so the reference angle is just going to be the difference between those it's pi sixths. So the problem I have to do, sine of 7 pi sixths, I don't know what that answer is. It's not one I've memorized. So I'm converting this hard problem into an easier problem. So that's my first step. Find the reference angle, convert the hard angle into its easier reference angle. Now, second step is get the exact value of sine of pi sixths. In your mind, I hope you're thinking, oh, that's like sine of 30 degrees. And hopefully you've memorized that. That's 1/2 again. So sine of 30 is 1/2. Sine of pi 6 equals 1/2. Now we have to decide, is it positive or negative? Question mark. Positive or negative? So a smart trig class. We're in quadrant 3 again, which is positive for tangent, but it's negative for sine. So we had 2 in a row. This is a coincidence. They came out as negative 1/2. Let's try another one of these. 7 pi fourths. Tangent of 7 pi fourths, I do not know what that is. I haven't memorized that. How are we going to figure it out? Well, we're going to convert it into its easier form, the reference angle. But we need to find the reference angle. So if I draw pi, that's a half circle. Does that make a picture for 7 pi fourths? Well, pi is only half a circle, and it's 1 whole pi. 4 out of 4 is 1 whole pi. It's too small. So I've got to go further, but do I go a little further or a lot further? 7 pi fourths seems like more than before. How much more? Well, just to kind of back up a little bit, how much is a quarter of a turn? Well, 4 pi fourths is half a circle. 2 pi fourths is a quarter of a circle. So I'm going to add a quarter of a circle to my half circle, and that gives me 6 pi fourths. And now I know that 3/4 turn on the circle is 6 pi fourths. My angle is not big enough yet. My angle is going to have to go all the way over to here. There's my angle, 7 pi fourths. Now, what's my reference angle? Well, remember, the reference angle is off of the x-axis. It's over here. There's the reference angle in red. And the reference angle, if you'll notice, completes the circle all the way to 2 pi. So if 2 pi is here, I've got to find the difference between 2 pi and 7 pi fourths. But 2 pi is a whole number 2, so I'm going to multiply it by 4 over 4. I know some of you are rusty on fractions. And so 2 pi times 4 fourths makes 8 pi over 4, right? Because 8 divided by 4 is 2, a whole number 2 pi. And now I can see my reference angle is the difference between those two. 8 pi fourths minus 7 pi fourths equals 1 pi fourth. Okay, so this hard problem I'm trying to do, tangent of 7 pi fourths, I don't know what that is, but I can convert it into something easier. It's tangent of pi fourths. Now later, we'll have to get the positive and negative value figured out. But we can do tangent of pi fourths. Now hopefully you're thinking the easy way, oh, that's tangent of 45 degrees, which I've memorized. Tangent of 45 degrees equals 1. Tangent of pi fourths equals 1. But is it positive or negative? Well, let's go back to the quadrants here. A smart trig class. We are in quadrant 4 and cosine is positive in quadrant 4. So we can deduce on this problem that the tangent must be a negative number. So we've got to choose a negative answer. So tangent of 7 pi fourths equals -1. We were able to calculate those pretty quickly, and the faster you get at finding the reference angles, the faster you can get these exact answers. Let's practice a little bit more here. Now, if you're using my lecture notes, I believe question 1 and question 2, you may have different numbers. So I changed them to 300 and 240. Now these first two are in degrees. We have not memorized the cosine of 300 degrees. But if we can find the reference angle for it, we can change the hard problem into an easier problem. So there's 90, there's 180, there's 270, there's 300 approximately. And the reference angle is going to connect me to the x-axis. That's the reference angle. And so we've got to subtract. So that takes me all the way to 360. And if I subtract 300 and 360, I find the reference angle is 60 degrees. All right, so this hard cosine that I've never memorized, I can switch it to cosine of 60. Now, we're switching it to 60 degrees, the reference angle, because it's going to have the exact same answer. But all I have to do is figure out the plus and minus part. So first thing was find the reference angle. I found it at 60. Second thing, answer the value. What is cosine of 60? And you've memorized that. Cosine of 60 is going to equal 1/2. Lastly, we have to decide, is it positive or negative? So when we go in and use our little acronym here, a smart trig class, we are in quadrant 4, and cosine is positive in quadrant 4, and I'm doing a cosine problem, so I need a positive answer for this. Now you do not have to write the plus with the positive answer, but I'm just putting it there for emphasis. Let's do another one with a degree, 240 degrees. This time it's sine. So first thing, we've got to find the reference angle. Here's 90, here's 180, here's 270. That's too far. So 240 is going to stop right around there. And my reference angle, he's got to connect back to the x-axis. So there's 180 back to the x-axis. And so if I want this reference angle, I'm going to have to subtract 240 and 180. I get 60 degrees. So this is going to allow me to change my hard problem into an easier problem. Now, I also, well, not now, but next, we'll also have to come back and figure out, should I choose a positive or negative answer? But sine of 60, I've memorized that, and I'm hoping you've got them memorized as well. That equals square root of 3 over 2. Next, I have to determine, is it positive or negative? So we go back to our acronym about the quadrants, a smart trig class. We are in quadrant 3, and over there, tangent is the positive one, but not the sine. So I have to choose the negative in this case, and there is my answer, negative square root of 3 over 2. Now, that's what I'm going to be quizzing you on, where you take a radian or degree, find its reference angle, and then calculate the sine, cosine, or tangent of that reference angle and give me an exact value. That's the main thing I want you to get really good at. Now, those of you in my class using Newton, they do have a few other problems where they're asking you to write the final answer in terms of the reference angle. And if you're writing in terms of the reference angle, ultimately what that means is you don't need the ratio. So if I'd actually followed the directions, number 1 for the computer program would say positive cosine of 60, and we would be done for these directions. And on this one, we would have said negative sine of 60, and that would be done for these directions. But on the quizzes that I'm going to give you, I'm going to want you to give me the final ratio. Now, numbers 3 and 4 are a little bit more involved because these are much more complex angles. But you're going to work on the same way. Number 3, we need the reference angle. So let's draw a picture to help us see what the reference angle is. Okay, so if I do a half circle, that's pi. And 1 whole pi is 36 out of 36 pi. Because 36 divided by 36 is 1 whole pi. And I got to go 57. So that looks like I got to go a ways past half circle. But how much past? I don't know yet. Just to help me orient, I'm going to find out, do I go a quarter turn or less, or a quarter turn or more? And so I'm going to back up to find out this number. And that's just half of 36, which is 18 pi over 36. And so if I go 18 plus 36, turns out I get 54. So another quarter turn takes me to 54 pi over 36. And 54 is too small. I've got to go further. So that tells me I'm going into quadrant 4 now. I'm going to erase this because I know I went past. And I am over here, 57 pi over 36. Okay, I need the reference angle for that. Now the reference angle is going to have to be this one off the x-axis. And notice how the reference angle takes my black angle and completes it all the way to 2 pi. So I'm going to have to subtract 2 pi and 57 pi 36ths. I can't do that because 2 pi isn't a fraction. So I need to take 2 over 1 and times the top and the bottom by 36 so that both fractions are out of 36. Now 2 times 36 gives me 72 pi out of 36. And 72 divided by 36 is 2. It's a whole number, 2 pi. And now I can see what to do for the reference angle. I have to subtract and find the difference there between the black and the 2 pi. So when I do 72 minus 56, I get 16. So this reference angle here is 16 pi out of 36. And it turns out to also be reducible to 4 pi out of 9 if I divide everything by 4. So I've got my reference angle now. Okay, so I can simplify this problem. It's going to become sine of 4 pi ninths. And I have to make a decision about the positive and negative. Okay, so let's decide about the positive and negative right now. We are in quadrant 4, a smart trig class. Cosine is positive in quadrant 4, but not the sine. So I'm picking the sine. Now, for those of you doing the Newton homework assignment, the final answer is negative sine of 4 pi ninths. The directions say write the answer in terms of its reference angle, and we've done that. Now, whenever possible, it's great if you can, like on the quizzes, I'm going to ask you for the ratio. Now, this is not a ratio we can do because we have not memorized 4 pi ninths. So we're stuck. We can't get an exact answer with this. And we're just going to write it in terms of the reference angle and be done with it, and the computer assignment will accept that. If we needed the ratio, we would have to use the calculator and get a round off in the calculator. I got one more of these I'm going to do just to help you connect to these radians better. Cosine of 19 pi 18ths. We got to find the reference angle. And I always start with a half circle because I know that's pi. And I try to see how that drawing of a half circle relates to the angle I need. Now this angle is out of 18ths of pi. So 1/2 circle, which is a whole pi, is 18 out of 18, 1 whole pi. And that drawing isn't big enough for what I need. I need to go just a little further to 19 pi 18ths. And my reference angle then is going to be off of the x-axis. Right there's the reference angle. And I can get it if I subtract the difference between the pi and the 19 pi. And so the reference angle equals 1 pi 18th. All right, so this is actually for that problem above. I'm just using the space down here. And so this hard number 4 question, I can change it into an easier question because I have a smaller reference angle now. They have the same numbers. But I also have to choose, should I use positive or negative? Now the last decision there, positive or negative, we'll use our mnemonic memory device, a smart trig class, and we're in quadrant 3, tangent's positive down there, but that means cosine is negative. So here's my final answer. Now the reason I'm saying final answer is because we have not memorized the cosine of pi 18ths. So when Newton says in terms of the reference angle, there's the reference angle. So number 4 equals that final expression, negative cosine of pi 18ths, in terms of the reference angle. Now it does have a ratio, but we're not asked for the ratio. And if we wanted that ratio, we'd have to plug into the calculator. But we don't need to do that for these directions. The directions didn't ask for the final ratio. They asked for the expression in terms of the reference angle. So I'm not going to do those other two with the calculator, but I wanted to give you plenty of exposure to reference angles, the reference angle property, and working with radians. Study hard on this stuff, you guys, and good luck with it, and I'll see you in class.